Hello, everyone, and welcome back to yet another episode. We've got Alessandro and Walid joining us today for a session on building specialized AI systems. Uh, Gentlemen, before we start, I think it would be good to just see if we have some people with us, just to confirm. So, if you all have joined us live and you can see us, hear us, why not just drop in hi in comments and tell us where you're joining us from? We'll just give it about a few seconds before we start, just to see that, yeah, we're not alone talking. In case we are, that's fine. We'll just carry on. But let's give it a few seconds. Hmm. I can see quite a lot of people are joining in on the stats. All right, well, people may be shy. So, yeah, in case you join us later, just drop in a line. There's our first comment. Amir Sajjad from Pakistan is joining on YouTube. Hi, Amir. I think he was one of the winners for the last book raffle that I did. Yeah. Uh, so people can see us. So Alessandro and Walid, if you all can just introduce yourselves, that would be helpful for people to understand who you are. And while they're doing that, if you all have any questions for both of them, please feel free to add it in the chat. We'll take it uh, after they've introduced themselves. Gentlemen, over to you.
Walid, you go first.
I think Walid is trying to figure out how to
Yeah,
unmute
let
himself.
me. I think I have it now. Do you
Yep.
guys hear me fine?
Yes.
Okay, perfect. So essentially, so basically, I'm the founder of UBAI. So we are basically we started as a data labeling companies. So
Hmm.
basically, help companies create the the data set to fine tune their own AI models. This was back in 2021, I think. And since then, we basically transitioned to fine tuning. So we help companies move to the next stage and then use the data labeling part to fine tune their own model. So we are basically essentially a combination of data labeling platform plus fine tuning, and the goal is to specialize models for your own business. So yeah, we've been operating since 2021. I'm really excited to write this book with Alessandro today. And yeah, happy to get any questions and answer them.
Thanks, Walid. Alessandro?
Yep. So I'm Alessandro Negro, and I'm the Graphoware chief scientist. I spent the last 15 years of my career at the intersection between graphs, machine learning, and recently large language models and generative AI. And I also authored two books already before this adventure. So this is my third time already. So it seems that I'm not as good as I should be in learning the lessons of how complex it is and time consuming is a very good book, but definitely I enjoyed it quite a lot. And I like to share a bit of the experience that I learned in these years of practicing around large language models with knowledge graphs and with other setup or in building a agentic solution that leverage graphs and fine-tuned models for delivering high quality intelligent systems to the end user. So let's say if this book will teach people something useful for them.
Perfect. Thanks, Alessandro, and thanks, Walid. So I can see quite a few people have started commenting hashtag AI. So yeah. So just in case anyone's wondering why they're doing that, people are commenting hashtag AI because there's a ticker going on at the bottom over here. The ticker reads that two people will stand a chance to win early access book that Alessandro and Walid are writing. So yeah, if you want to be one of the winners, comment hashtag AI. And we have quite a few people joining in. Vinayak says hi, joining us from India. Hi, Vinayak. Alexandre joining us from Brazil. Hi, Alexandre. So, any questions that you all have, please add it in the comments. In the meantime, I'll get mine answered. So, first question for you both, Walid and Alessandro.
Yeah,
When is a general purpose LLM not enough for a real business problem?
I can take a start with that. So I think the question is not a general purpose LLM is not enough. I think the phrasing is slightly different. It's basically, is the general purpose LLM reliable enough and consistent enough to deliver, 95% accuracy or higher for whatever business need you need. So if your goal is simply a summarization that doesn't require like high accuracy, probably general purpose LLM is enough. But if you are in like a mission critical, you have a business case that's mission critical, let's say like it's in medical or finance, and you need the accuracy to be 95% and higher and reliable. So if you run it 1,000 times, you're going to get 1,000, the same response every single time. Then you probably need a fine-tuned specialized model. So the general purpose LLM is basically, it's generic, so it has a lot information, but it might not be specialized to your specific business process. So it might work sometime, but some other time might fail because of the stochastic nature of the model. So in that case, you need to basically specialize in and adapt the model for your own business process. Yeah.
Thank you.
And also, as we explained, in our book, the thinking is that we should identify always the right tool for the right job. And in this case, this fine-tuned smaller model can serve the purpose at the same level if we train them for the specific task, as Walid was saying, and you can save even a lot of money. So even cost consideration sometimes could drive you to use a smaller model that you can run on a commodity hardware, so reducing heavily the cost. Based on our experience, sometimes it happens that you start a project, you deliver energetic infrastructure, and then you realize that offering these to a larger set of users will increase your costs, because of the costs charged by generic or general purpose models. So these smaller models that have been fine-tuned for specific purposes can, serve also as a cost-saving strategy for your production-based solution.
Yeah.
And again, there are then other considerations about the specificity of your domain that could justify the need of such a specialized model.
Thank you. I can see quite a lot of people have seen the ticker and they've commented hashtag AI. Thank you and all the best. And if people haven't commented yet, please feel free to do that. Uh, so Alessandro, you mentioned fine tuning. So I think it's an important time that like we pick this up. So how do you know when to fine tune instead of just prompting better?
Well, generally, as we suggested, you should always start with prompting, in the sense that prompting is definitely a good approach. But at some point, you will reach some plateau, some performance plateau, where clearly you can't go further just by adding examples and examples, because you have limitations in terms of a context window, but also the point is that what we noticed with experience is at some point you can get the LLM to be confused by too many instructions, for example, or by too many examples. So in that case, when you reach this plateau, you reach the limitation of what you can do by fine-tuning your prompting. Your prompt, definitely the next step is to start thinking about passing all these examples that you created for the prompt as a fine-tuning data set that you can use to tailor a smaller model to serve your purposes. So in this case, you can get a more stable solution even without relying on this big model. And even here, there are a few examples in the book where we show where the domain or the task can switch from a generic prompt strategy or a better prompt strategy to a fine-tune model solution, actually. I don't know, Walid, if you have some other points here.
No, that's really that's a good answer. Yeah, but I
You've
think I see
summarized it
more
pretty well.
questions here.
Yeah, you've summarized it pretty well. And I think you've got a friend joined in as well, Stefan Wenden. Greetings from Sweden. Welcome, Stefan. There's a long question from Amir, so bear with me on this. So, what are the most common architectural mistakes in specialized AI systems, especially when deciding what belongs in the model, RAG tools, agents, or deterministic business logic? Oh.
Yeah, that's a good question. So I think this is very involved questions, and might take an hour to answer. But I'll try to make it a bit more concise. So essentially, it depends on what you're trying to achieve, right? So if your goal is just like a chatbot, you just haven't, uh, that's support, a customer support like chatbot, and you just wanted to answer like factual, factually basically based on a knowledge base. Then in that case, you probably just need RAG, right? You just need like use a regular, AI model, generic model, and then just layer on top of a RAG, and then basically it's going to be more factual. That being said, if you let's say you the same chatbot you wanted to answer in a specific way, like an empathic way, like empathy, or maybe a very specific helpful way that your business always kind of relies on, for your clients, then in that case you are basically we're talking about behaviors. We are changing the behavior of the model, and you cannot really change the behavior of the model just by prompting. So in that case, you will need to change the weights. Basically, the weights is almost the neurons in the brain. So you have to adapt the weights to the desired behavior that you want to achieve. So that's where fine tuning comes in, right? So if it's just like knowledge base, fine tuning is definitely not for that. Uh, RAG is perfect. Now moving to the tools and agents. Um, so actually, fine tuning can be super helpful as well for that, especially for the tool selection, right? So if you have an agent, you give it 100 of tools, and then you basically, just try to give it a task to do, and you hope for the best, right? Like hopefully, it picks the right tool, use the right information. In that case, actually, fine tuning can also help in tool selection. So you can actually give it examples of multiple ways of selecting the tools, and then that will make it much more efficient, making less error in tool selection and so on. The final thing with agents is, let's say you have a specific action you want to take, like for your business process, and you don't want to go in a loop, right? Like maybe make a mistake, going back, correcting that mistake again and again. In that case, fine tuning the actions, like what action to take, what tool to select, can actually make the entire process much more efficient. So it really depends on the business case. I think the first step is really to map your business process, and most importantly, also having a success metric, right? Where how do you know, if the AI model did the right thing or not? So you need to have evals, evaluations. So that's typically the first step.
Thanks, Walid.
And also, sorry, let me just add a few notes on what
Yes,
Walid said, because I think that there is also a bit of misunderstanding when we make these tools in comparison to each other, because if we would like to develop a complex intelligent systems, you can literally combine all these techniques to achieve your goals. For example, if you're using an agentic RAG, definitely these will require multiple agents that will make a different type of reasoning. And you can decide that for one of these reasoning steps, you can involve, for example, a fine-tuned model. So actually, it's not about selecting which of these solutions is the best, but the real question is how to better combine all these solutions to get an ecosystem of solutions that can can help you to develop the intelligent system that you have to realize, to bring to production. And what we notice is that whenever you come to the agentic world in particular, I mean, definitely you will need a RAG if you like to bring knowledge from external sources, so you can't get out of this. So you definitely need to use a RAG. But in your agentic, there will be some reasoning steps where, for example, the generic or general purpose LLM cannot provide the right reasoning that is narrowed down on your specific task. Then it's the turning point where you said, okay, let me switch this component, this node, for example, in a land graph approach, with something that instead of calling the general purpose LLM, we'll call a fine-tuned model that will be able to do some tiny piece in this bigger architecture, but it's exactly the piece that you need. And the same is for the business logic that we mentioned here in the question. Probably another piece will be just business logic that you don't need even to rely on external services. It's just something that you can program, you can develop. Sometimes we've got these questions, in generic terms of, as all the other solutions will disappear from the world. In reality, it's really about combining all of them to get, the right setup for answering the complex question or to achieving complex goals.
And we have a section in the book actually that outlines exactly a flow chart, that you can follow to figure out like what you need exactly. So we had the whole section about that. So check it out.
Yep.
Thanks for the question, Amir. There is another massive questions coming from Orlando on LinkedIn. It says, considering how data changes dynamically, is there perhaps better value in giving the models tools access to appropriate data sets to complete their tasks as opposed to constantly make the fine-tuning effort?
Yeah.
It's a good follow-up.
Yeah, I think it really depends. I think it's hard to answer this question without understanding the business process. But as a rule of thumb, I think if your data keeps changing constantly, in terms of, if you think about it in terms of distribution, right? Like if it keeps moving, in that case, probably fine tuning is not useful. Because you want to fine tune when the behavior is you're trying to achieve is kind of repeatable. Let's say, for example, classifying financial transaction, right? So you don't have hundreds of thousands of financial transactions. You might have, but whatever the universe of financial transaction, you can basically encode that into the model, like fine tune it on to classify correctly. So you know what to expect, right? But if you don't know what to expect, like it's very like broad, like open ended. I think fine tuning is probably not good for that. And what I think Orlando mentioned could be a better idea is using tools to go find that information from one place or another, or like a RAG or a database. So yeah, I think that's kind of the key is having the context or the boundaries defined around what the model should do, and that's where fine tuning I think is really powerful.
Well, and also it again really depends on what you are trying to achieve, and the type of data dynamic you have, because as we said before, still RAG is a valid solution if you have a knowledge base that evolves constantly. So in that case, as Walid suggested, definitely fine tuning is not the right solution here. But for example, if instead you are referring to dynamism, where, for example, you need to capture user preferences and you would like to adapt to these user preferences, well, there are other fine-tuning techniques that we also illustrate in the books, like reinforcement learning based on human feedback or GRPO. So these are techniques that are well designed for addressing the type of dynamics that you are speaking about, in which you get a lot of feedback from the users and you would like to adapt quickly to these feedback to adjust the reasoning behind the scene in the model. So really, again, if your dynamism is related to the data that belongs to your knowledge, then I will go for a RAG and building a system that will update your knowledge base constantly instead of updating the fine-tuned model, because this would be impossible to do, literally. But on the other side, if you like to have a fine-tuned model that will, address the changes in preferences dynamically, because we would like it to change the reasoning effort or the reasoning internals, then probably these other techniques could be better.
Yeah, maybe a concrete example could help. So let's say, for example, like I mentioned earlier, so let's say you have a classification task, you want to classify like a type of transaction, or maybe like reasoning or explaining like some type of transaction, is it fraudulent or not fraudulent, and you have a specific type of reasoning that it should go through. In that case, fine tuning is perfect for it because you are changing the behavior to adapt to the reasoning of your business. So the reasoning of your business ideally does not change, right? Like, or from one day to another, within specific industry, within sub industry, you have a specific way of thinking about things, to reason about things. So in that case, fine tuning is perfect, right? But if you're just like fetching the data, maybe something changes the data, the input kind of data changes a little bit, then yeah, I think using different tools and RAG would be good for that.
Perfect. Thank you so much. I think this is exactly where specialized AI systems come into play, right? You cannot use off-the-shelf models. And speaking of, what problems do specialized AI systems solve that off-the-shelf models can't?
Yeah. Again, I don't think this is a replacement. um, so I think generic AI models can solve a lot of things, and I think right now, like if you look at the benchmark, that like a really PhD level kind of understanding of things, like from physics to chemistry to whatever you can think of. But I think the key here is if you wanted to make it, as I mentioned earlier at the beginning of this talk, make it reliable, consistent, very, very accurate at that specific task for your business, then you definitely want to fine tune for sure. Because specialized AI models can give you an answer, which can look good, but then when you look at the edge cases, you're going to see a lot of failures. And that's because just the nature of the pre-training. So it was trained on archive, on Reddit, on GitHub repos. It wasn't trained on your specific, business process. So it might work from at the surface level, but then when you look at reliability, you repeat it 1,000 times, you do evals, you're going to start finding edge cases, and then you will try to encode those edge cases in prompts, which might work for a while, and then you discover new edge cases. So in that case, that's basically a sign that you're ready to fine tune, essentially. So yeah, that's how I frame it. I don't think they are like specialized AI models are going to replace generic AI models for everything, but they will replace them for a specific task.
Hmm. Would you like to add on to it, Alessandro?
No. I think that Walid
Somebody
was
else.
best positioned to answer this question.
Perfect. All right. We'll take the next question. Oh, I see that there is a question from LinkedIn. So Brian on LinkedIn
Okay.
asks, what are the rules of thumb for when to just use RAG versus upgrade to graph RAG versus upgrade to ontological knowledge graph RAG? I can see Alessandro smiling over there with with graph coming
But
in.
yeah, because actually I'm struggling to understand what is this ontological knowledge graph RAG, because this RAG is getting more and more adjectives every time that I hear about it. So we started with just a simple RAG, then a graph RAG was added, then agentic RAG, agentic graph RAG. So I was smiling just because this ontological knowledge graph RAG is something that honestly I've never heard in my life. So far. In general, what I like to say that when we speak about RAG, to me, it means everything. The idea behind RAG is something that we found very powerful, as I said before, for introducing knowledge base in the process. So knowledge that is not available in the weights of these general purpose modules. But in general, it's always the best solution, even when this knowledge is embedded in the general purpose models. Then the way in which we implement it depends on many, many factors. There is no rule of thumb because it depends on the sites. Just to give you an example, using GraphRag will require an enormous effort upfront for building the initial knowledge graph, which makes totally sense if this is an high sensitive, let's say, task. So you would like to decompose the text in multiple, entities, relationships, and definitely it's worth spending the time if you need to do it. But this will move the cost, quite high in the early stages of the project. That should be justified by the use case. And again, imagine you have thousands of documents that you have processed, and each document has hundreds of pages. The cost at the time for completion this would be enormous. In that case, the suggestion would be to use an agentic RAG in which you have a simplified version of the structure behind, still using a simplified graph RAG, but without extracting, for example, entities, and then empower the agents with a lot of tools that could scout the graph database to extract the data at that point. So that's a solution. Then the more complexity you add to the initial stages will have a cost. That in the other case you pay later when you have the question. So my suggestion generally is to move the complexity later, because it's when you are literally using the model. If at that point you notice that this is becoming too much, then you come back and say, okay, maybe that I can add a bit of intelligence earlier, so that the later stages will be simple. So that's basically what I can suggest here. Again, this is a bit outside of the purpose of our book here. Probably you will find more information in my previous book, but not in this one, because here we are focusing on the rule of fine-tuning in building a complex system. And again, in the book we are speaking about how to combine all these technologies together. But of course, when we come to the description of the details, we describe the fine-tuning solution, the approaches as the ones that we would like to promote in this book. Then, of course, you can combine other books, as I said, like my previous one, to know better what is RAG and what is graph RAG, and how it could be useful for your use case. Then I will definitely look at the internet and check what is this ontological knowledge graph RAG.
Yeah. What would be the name of your previous book, just for Brian's benefit?
Knowledge Graphs and LLMs in Action,
Perfect.
edited by
Brian.
Manning.
Yep, it is by us as well. So Brian, go and check that out. That would definitely help you. I'll ask my final question before we begin the first raffle. So if people haven't checked, there are so many people commenting hashtag AI. I think we've got about 13 entries, and I can see about 68 people live. So if you want to win the early access of the latest book that Alessandro and Walid are writing, comment hashtag AI. I'll get my final question answered, and then we'll do the first raffle out of the two of them. So, gentlemen, the next question, why do so many fine-tuning projects fail before they reach production?
Yeah, it's a good question. So I guess from the experience I have with this domain of data labeling and fine tuning, seeing like a lot of companies try to fine tune. I think the main issue is the data quality, and so essentially, uh, let's say you have you're trying to fine tune a model on like reasoning, right? Let's say like it's a legal task where you have to reason about a specific legal case. In that case, if you have like instruction tuning data set, like a pair of question answer, and you give that to multiple people within your organization, and you have multiple people kind of disagreeing on that specific task, now what you end up with is basically your subject matter expert are not agreeing on the actual outcome or the result of the task. So if your subject matter experts or your data, whoever is creating the training data, the data labor are disagreeing, then you're basically feeding kind of ambiguous data set to the model, and the model end up learning very poorly and does not really generalize. So I think the first step is really agreeing with your team on what should be kind of what are the kind of the guidelines and the rules we should follow to provide like the the answer to the model. So that's typically the first step. I think a lot of people, a lot of companies, we see like skip that part. So they will just use like one single labeler, or there'll be some quality, changes like within one data set to another, and that basically end up confusing the model and making it even worse than the baseline, essentially. So I would say like. The dataset quality is the first one. Finding all the edge cases, providing positive and negative examples also can be helpful. And before we even go to the data set, typically what we've seen a lot of companies skip the eval step. Essentially, before you even create a training data, you need to measure your baseline. So using your best prompt with your best few sharp, best in context learning, whatever you can come up with, what is the baseline that you want to be above, basically. So a lot of people skip that eval, so they don't even have evaluation metrics in place. So what I've seen is like missing the eval part, which is evaluation of the baseline model and having that evaluation data set. And second is creating the training data with really high quality, where everybody agrees on what should be the input, what should be the output. So I think those are the main failure modes we've seen when trying to fine tune models.
Perfect.
And also, I would like to add just a simple thing here, because in reality, fine tuning is no more no less than what we have been experiencing in the last probably 30 years, about building models in other fields. So the simple thing is garbage in, garbage out, garbage
Yeah.
out. If you don't rely on the quality of the data that you use for training it, and when I say quality, it doesn't mean just how they are structured, but also what we noticed with Walid, in these years, is also that it's important to give enough variety to the data to learn from different experience. Sometimes, we see data set that are very specialized on a specific problem, forgetting that there are tons of other problems. So really spending enough time in evaluation first, because you need to know exactly what is the metric of your success, if your fine tuning will go well, is key, as Walid said. And on the other side, really spend a significant time on the quality definition of your data set, and then the creation of that quality, because otherwise you will end up with a really let's say rich data set that will express only one aspect of the results that you like to get. So you will get a very high quality in the end, but the reality is that it doesn't work in production. So when you reach the production, you will notice that the type of problems that you have to solve are way broader than how you tune your LLM model. So that's really the higher risk here. So think about the different type of problems that you could face during the production. Train your model for that, and this will definitely increase the chances of success in the end. But again, this is not specific for the fine-tuning of this model. This is a rule that's applied since ages, probably when we are speaking still about machine learning many, many, many years ago.
Yeah, I agree, and I think we have totally. I mean, it's difficult to fine tune. I'm not saying it's easy, sure, and there's a lot of traps and pitfalls and things like that. So we actually kind of gathered all our learnings over the years. So we have like a chapter 8 will be about all these steps, and if so we try to kind of give the best practice for AI practitioners. What are the pitfalls? What are the traps to avoid? And the good news is, the good news is really you don't need a lot of data sets. Right? We're not talking about like OpenAI terabytes or whatever, like so many data. You just need 500 examples, 500 to 1,000 examples. Typically, you need within that ballpark 500. The more, the better. But even with as low as 500 examples, like really highly graded examples, you can really end up with really high performance of the model. And this is, we're not going to go into the details now, but basically, there's the I guess a few years ago, I'm not sure when exactly, but there was a technique called LoRa adaptation, which essentially allows you to not fine tune the entire model, but take a small subset of those weights and fine tune those subsets to your specific task. So you're keeping the generic knowledge of the model, you're just adding a new small subset. And you plug into the existing model to basically make it specialized, and that basically make it, you don't require a lot of data sets. As I said, 500 examples might take you a week of your subject matter expert, let's say lawyers or junior lawyers, get them together, create like a 500 high quality examples, and you already solved a lot of issues, right? Because you hear about every week there's like a new term: harness engineering, loop engineering, context engineering. And for me, this is a kind of, I mean, it's very important, like, all these things to do, but they're basically pointing to a symptom. You're trying to basically, it's in the name, like harness. It's almost like a wild horse that's just going everywhere. So you're trying to basically contain kind of these, idiosyncrasy of the model, this probabilistic nature of the model with these, additional loops and verification, another model checking another model, which is basically creating even more, token consumption, making the whole system more expensive. So for me, it's like it's important, I think, to have those checks, but they should not be. Trying to patch, the model kind of, inaccuracies. So in that case, probably fine tuning would probably be better, more cost effective, more efficient. Yeah.
Perfect. I can see quite a few questions have come in. I'll take that a little later. We've got the first raffle to do. By the way, Brian mentioned somewhere that he's sitting to that knowledge graph book right now. There he is. So yeah, he already has that. Okay, I'll share my screen and we'll do the first raffle. Can you see my screen?
Yeah. Yeah.
Okay, so there are 17 people who've entered the raffle by commenting hashtag AI. If others haven't, please do it for the next one. Here's the first raffle now. Let's see what happens. These are all the people who've entered in so far. So Satish Krishnan on LinkedIn is the first winner. Congratulations, Satish.
Congrats,
Um,
Satish.
yeah. Drop me a line on LinkedIn and I'll coordinate you getting this ebook. Early access, in fact, not even ebook. So others, please feel free to comment hashtag AI. There is still another raffle towards the end. So yeah, you still stand a chance for it. I saw another question from Brian. What is the very best possible use case for fine tuning? What is a case where fine tuning was a major success?
Yeah, I think the main tasks for fine tuning was a major success. It's always in the deterministic task, I would say. Classification, name entity recognition, um, you know, maybe like if you want to like output specific structure, you want like a specific JSON structure, so in a specific deterministic way. So any deterministic task, usually fine tuning is really good, and it can in many cases beat even generic models. Now, when it comes to reasoning, like let's say tool selection or maybe like coding. I think it requires a little bit more data, but yeah, it's possible to basically get good performance as well. But you need to be very careful about the data set. But yeah, definitely deterministic tasks will be best for fine tuning.
Alessandro, do you want to add anything, or are you happy for me to move on to the next question?
Well, no. I'm fine. But I would like just to add a few basic notes again on
Yeah.
generic type of approach. What we noticed so far is that sometimes people start projects with the idea of fine tuning, and so they try to find where the fine tuning can work on, and they also sometimes push too much in the direction of using it just for the sake of, trying it. The most successful projects are those for which fine tuning is really the solution. So is actually the best solution after you tested all the others. As you said before, if you can achieve the same goal with fine tuning your prompt, do it. With a bit of prompt engineering, you can get definitely good results. Walid, for example, is experimenting a lot of this with DSpy or whatever is the tool that you're using Walid for optimizing the prompt, for example. This is delivering very good results without having to fine tune it. Sometimes with RAG or in graph RAG, you can get a lot of adaptation to domain knowledge that doesn't require fine tuning at all. So the book teaches explicitly when fine tuning is your tool to go, and this is definitely the path to success. Because if you try to use fine tuning for the wrong problem, definitely you are not setting up for success here. And this is what we notice many times, but not only for fine tuning, but this applies for any other technique that has been proposed so far around AI. So be careful about using the right tool for the right
Yeah,
job.
I mean, definitely don't start with fine tuning. I know it's kind of against the book, but usually there's like a workflow, right? You start with your defining your business process, defining the evals, the model baseline, and then basically, if none of that work, basically you move to the fine tuning essentially. So definitely recommend to check, make sure you've exhausted all the other possibilities before you move to fine tuning.
Okay. Let's move on from fine tuning for a bit for now. My next question is about what are the biggest mistakes developers make while building AI agents?
Yeah. I think. Yeah, so AI agent. Okay, so we're talking about the AI agent. I think the main issue is, like we discussed at the beginning, delegating too much to one single model to do everything, like even from tool selection to summarization to reasoning to writing code and do all of that. So if you are giving all those tasks to one single agent, uh, typically, and you expect, obviously your business process requires high accuracy, 90% higher for specific tasks, then probably I think that's kind of the biggest mistake. Yeah, it's like you have to
And
define what is the best for specific task.
yeah, I can also remember an interesting article from Anthropic many years ago, where they were speaking, they were literally introducing the concept of agents, and they said that the agents should be your last, let's say, approach after you created, for example, well-defined workflows. What we noticed is that in reality, people think that, as Walid said, that you create an agent, you instruct it with a simple prompt, and then with this React agent, you can do whatever. The system will create the code for you, will run everything just in a single box. This is going to fail because what we notice instead that the highest rate of success will be achieved once you can define the workflow. So you have a fixed workflow that would achieve the most of the cases, and then potentially having a fallback that will say, okay, with this fixed workflow, I can't reach the scope. Let's try to get into the wild and ask an agent to do the last attempt. But the reality is that for many of the tasks that you have to accomplish, sitting for a second and thinking of a more structured workflow will give you a more, let's say, stable answer, or at least a solution that you can rely on, because this will allow you to get controlled results. With the agents, sometimes with a small prompt, without fine tuning, probably you will get really very randomic answers, which is not something that you can rely on. It's not something that your users can rely on. So start with workflows and get that are still agentic. That's a bit of misconception, because sometimes we think that, if I have to define the workflow, then it's not agentic. This is not completely true, because when you go agentic, it doesn't mean that you have a single agent that will do all your work. You have multiple agents that will cooperate to achieve your goal. And in this case, you can specialize each agent to, for example, in one of our use cases, we have an agent that is specialized in retrieval strategy. So it just uses multiple tools to retrieve what you need. And then you pass the ball to another agent that will evaluate the results. And again, you pass the ball to another one that will generate the answer, and so on and so forth. Each of these can be considered an agent that will use the information in the right way, that will make the calls that are necessary to accomplish this goal, but you have the full control on the entire workflow. And then the agents will accomplish a small task. So specialization is not only fine-tuning the model, it's also about focusing the agent to do a specific task that is predictable and where you can easily evaluate the outcome of it. And this will drive you to an agentic configuration, definitely, but not where the agent, a single agent, will do all your work. So people, unfortunately, is taking this way. Okay, I will create an agent, I will pass a simple work prompt, and it will do the rest with a bunch of MCP server connected to it, and hope for the best. That's the path for failure, actually. Having this powerful tool doesn't mean that we should stop thinking. Actually, it's the opposite. We should think about how a human will do it with the intelligence we have, and then instruct properly, multiple agents to do part of this job, collaborate together, get the feedback from each other, and then you will probably succeed in this field. If some of these agents would require fine tuning, that's the way where you can identify again a specific scope. And coming back to a few of our answers before, then it's easy for you to enter inside the agent, alter the reasoning, alter the outcome with the fine tuning, and get your outcome. And that's where AI, let's say, becomes specialized, as we are proposing in the book. That's what we mean for specialization, not that everything is fine-tuned or you fine-tune for everything. You just fine-tune what is necessary. The rest of specialization comes in the, a bit in the way in which you structure the workflow.
Thanks. I can see that there is a comment on LinkedIn. There's a question from Dr. Riyaz Shakar. What are your thoughts on Prime Intellect's RLM? Do you think it will be the next AI tech revolution? Do we know what this is?
Unfortunately, I don't know. I don't know if Walid can answer, but I have no idea what it is.
Yeah, I'm not very familiar with it. I'm just looking it up. Looks like recursive learning thing. Yeah, I'm not sure I can answer that now.
Yeah, that's fine. Even I don't know what Prime Intellect's RLM is. No worries. My next question was, how do you evaluate whether a specialized AI system is truly improving?
Yeah, that's why I was saying, like, before you even start with fine tuning, you need to have a baseline. You have to know exactly what is the current performance of the non-fine tuned models before you get started. So that could be, there are different metrics you can use. So you have like a holdout data set, and then you measure, the F1 score, the precision recall. So there's a lot of metrics you can use. There's like a blue score, like measures the similarity between, the target answer and the output of the model. So there's a lot of metrics you can do. Sometimes it's kind of a little bit subjective. So you might need you need like your subject matter expert to go look at the data set and then the output of the model and compare them. Essentially, once you have that baseline performance set, kind of figure out, like let's say like 60% on the specific task, then after you fine tune the models, you will basically kind of have a holdout data set similar to the first baseline, and then you run the evals on that holdout data set. And then you basically compare both based on that one single metric, right? Like if you decided to do like similarity or F1 score, you want to kind of do apple to apple comparison. So yeah, it really depends on the task. The task will determine like what type of evals you can do, and from that you can figure out if the performance is increasing or not.
All right. I'll take my next question, assuming that Alessandro doesn't want to add anything. Am I right? Okay, perfect. There is a clarification from Orlando. Recursive learning models are being talked about in other forums. Very interesting technology in these. Okay, thank you.
Definitely check it out. Yeah.
All right. So my next question was, how can smaller specialized models compete with larger frontier models?
Yeah. Alessandro, go ahead.
I can start, Walid, and then you can complete my answer. Well, actually, as I said before, there are different dimensions under which you can evaluate your project. Definitely one is cost, because depending on your purposes and the, let's say, the target audience, involving large language models provided by big providers, could have a cost that could be quite important. And imagine that you are using it with a lot of text, but for a simple task. This will have an enormous impact on your business model, because you have to charge the users if you can. Otherwise, you have to find a better solution to get these your project. If you're talking, of course, let's say to a successful project, to get money out of it. So first of all, the cost should be one of the parameters that you should take into account while you are evaluating if it's better to use big models or a small model. Then there are other concerns. I read many articles of people, for example, running code completion or vibe coding using fine-tune models because they can run it while they are on a plane. This is just an example of saying that sometimes there are constraints that you have to take into account in your project about where you are going to run these models. Imagine that, for example, we operate a lot in the law enforcement space, and most of our customers operate in an air-gapped environment where there is no chance that any of these data will get out of their infrastructure. So the chances of using the large language models provided by Microsoft or Anthropic is zero. So in this case, what we have to do is to fine-tune models for specific scopes that will deliver high-quality results, alone without even accessing internet. The same could be for smaller devices. That imagine that you would like to use these technologies to deliver very specialized functionality without implementing it, or because we can't implement it. Then you can create smaller models that can run on a Raspberry Pi, for example. And then you can have these intelligence applied to smaller devices. Just to give you 3 examples in which you need to apply these type of techniques to get what you need. Again, it's not a competition here. It's really about using the tool, considering the constraints that you have for your project. That's my sort of quick answer. I don't know, Walid, if you have other scenarios in which this could be useful.
Yeah, I think we talked about it. Yeah, I think uh, accuracy. Obviously, I think like we discussed, if you want reliability, you want like consistency and accuracy for specific defined tasks. Definitely, I think specialized models would compete with larger frontier model. And in some cases, like it's like Alessandro mentioned, it's a no go basically to use any cloud, closed models, third party like provider. In that case, you don't have a choice really, so you need to use open source. And open source, we know, like they are typically lower performance than closed models, even though nowadays like Kimi K3 and new bigger models are coming out. But like, even if there's like an open source model that has the same performance as the closed model, you're not going to be able to run it. Those are like requires a huge data centers, 2 trillion of parameters and so on. So um, in that case, basically, you will take the open source model and then you fine tune it, so you reach the performance of closed model, with fine tuning. In that case, you're not sacrificing accuracy, you're not sacrificing confidentiality, you're not sacrificing privacy. So it's the best of both worlds. You're using what's available open source, you fine tune it to reach the level that you need. I think in that case, that's where I see it. Like, it's not competing; it's basically that's the only option you have, essentially, if that's what you need to do. Yeah, that's pretty much it. Yeah.
Thanks. I'm mindful of the time. I'll quickly take couple of the last questions. The last one would be about the book, but the final one over here for the session today would be: how can teams control cost, latency, and reliability when moving from prototype to production?
Yeah. When moving from prototype production. Yeah, I think that's a good point. Yeah, so I think for prototyping, typically it's okay to use closed models and like whatever like models available to show to demo it to your prospective customer or to your investor or whatever. But if you intend to make it like the requirement accuracy is high, and you intend to scale that up to thousands of customers, you probably in that case you start thinking about cost, latency, and reliability, right? So I think for prototyping, it's probably okay with using whatever the best model it is. It doesn't matter the cost, doesn't matter the privacy, whatever. But I think if you want to scale it up to production where all of these metrics matter, that's when you start thinking about like specializing the models. So if you want to go to production, I definitely recommend to start thinking about how do you specialize subtasks to make the whole system more reliable and production ready. Yeah.
Yeah, and coming back to what we said before, dividing the complex task in a smaller task will give you a higher chance to get, some of these latency, reliability, and even cost under control. And because you can, if you split this, you can definitely use the right tool for the right task, and then you can, instead of using the same model, for example, for all the intermediate step, you can just use smaller models for some of the tasks where you can use it, and use a bigger model for those where you need to control the output in a different way. So this will give you a lot more chances to get the costs under control, or the latency under control. And of course, my personal suggestion will be to take these three dimensions into account since you are developing the prototype. Not just adding these to the picture later on. So if you take them into account and you consider the type of users, what they are expecting in terms of latency, since the day one that you start designing your agentic architecture, this will definitely help you to create the prototype already taking this into account. Because sometimes it happens that you create a first prototype, you use your Azure OpenAI endpoint, and everything is smooth and performant, but then you go live and you discover that this will cost you an arm, to make it available to your users. And then you have to come back and you start using a smaller model without fine-tuning, and then you realize that it is super slow and not accurate as the previous one, and you have to redesign it entirely while you have a system in production that is burning money over money. So taking costs, latency, and reliability into account from the day one, even in the prototyping phase, while you are testing your solution, will give you a best path to success.
Perfect. I think, again, I'm mindful of the time. I'll definitely do the raffle, but just one final question before doing the raffle. I think I've lost a question in the comments, but this is the perfect time for it. There was a question by someone on YouTube inquiring what's different about your book. So I think this is the perfect time. There are quite a lot of books on AI. What's the main USP, or, yeah, why should people think of your book? I think it would be helpful to know.
Yeah, so I didn't think all the I didn't read all the books about AI, so I tried to give as accurate of an answer as possible. But what's unique, I think, in this book is really simplifying it, because I think fine tuning is a little bit abstract, right? You think most people don't know like what it entails, like what are the steps to do, and it might be a little bit intimidating, right? You don't know. It looks scary, right? Like fine tuning is only for big labs and so on. But I think what this really blueprint, right? Like a roadmap. How do you go from specialized model? How do you make sure you evaluate it correctly? And then it kind of goes step by step. Hold your hand along the way, making sure like you're following all the best practices that we discovered, me and Alessandro, during all these years. And then hopefully you end up with like a fine-tuned model that is giving you the performance that you're looking for. So it's not just like conceptual; it goes really into hands-on, without being too technical, right? So it's intimidating you from doing anything. So it's destined for basically managers, business leaders who like to take their system to production in a reliable and consistent way, without being super technical, like you don't understand anything. So we try to simplify it and make it easy to understand. But it has all the ingredients to basically show you exactly how to get it done.
And also, we approached the book with an honest, let's say, philosophy, in a sense that, as you will notice in the book, whenever you can go and use another approach, we literally suggest it, because we have the final goal in mind. And when we designed the book, we really wanted to help our readers to use the fine tuning in the right way, but when it's the right moment. So we keep an eye on the final goal. We come back and say, okay, in this scenario, fine tuning is what you need. In others, probably you should go for other way. And literally, the amount of code available in the book will help you to start immediately to practicing it. the rest of the book, like part 2 and part 3, will give you concrete examples of when and how to use it properly, in concrete scenarios. So that's how we structure the book, considering what's available already on the market. So our book is a good companion with other books available in the market. So if we mention, for example, RAG, of course, we are not speaking about RAG in detail. We are pointing to other very well-written books on RAG and even on graph RAG, for example, the same as for other techniques. We really wanted to focus on a specific area, that is fine-tuning this model to achieve and deliver specialized AI agents. And this
Yeah.
is what we are trying to address in our book, compared with others that are speaking, for example, about AI agents that are generic. We take from this and we say, okay, if we are developing an AI agent, solution, here is how you can specialize it, in your specific environment, for example.
Perfect.
Absolutely.
So, yep, as promised, I'll do the final raffle right now. I'll just share my screen. Our first winner of the raffle was Satish Krishnan on LinkedIn. We've got 19 more entries. So let's see who our next winner is very quickly. Grape TN user on YouTube is our next winner. Congratulations, Grape TN user. If you can just get in touch with one of us, me, Alessandro, or Walid on LinkedIn, ideally me. Just type my name, Tushar Gupta, as it says below my screen over here. And yeah, just drop me a line. Congratulations once again.
Congrats.
And thanks, gentlemen. Are there any closing thoughts that any of you have before we wrap the session? We've already gone over time. Oh, okay. Quickly, if you have any closing thoughts.
Yeah, I think basically uh, try to kind of be open-minded about fine-tuning. And I know a little bit, most people obviously jump into directly using the model, but be like systematic and methodical about if fine-tuning is needed. Start with, evals is so important. A lot of people skip it. Make sure you have all your evaluations in place, especially if you're going to production. And then basically think about how you're going to create the training data. There's a lot of interesting techniques that you can use in the book. We mentioned distillation, for example. So you don't sometimes you don't have the subject matter experts, but you can use the bigger model to distill the training data. So we talk about that technique as well, how to use it. It can make the process much faster, so you can fine tune much easier. And yeah, uh, I think it's going to be really important moving forward. I think exactly, especially where we are right now, the cost is getting much higher and higher every day with agents, consuming a lot of token. A lot of companies are thinking about token maxing as like really a recognition, but it's actually the opposite. If you are maxing the token. So yeah. Anyway, so as we move to production, this is the perfect time right now to think about fine tuning and learn about how to do it the right way.
Perfect. Alessandro?
Well, I think that Walid answered it perfectly. I would like just to add, if you buy the book, it would be nice if you can share your feedback on live book portal from Manning, because we are reading all the comments and we are using it to make this book even better than what we will be able to do alone. So feel free to share any comment there. Help us to make this a really powerful book for you and for all other readers. It worked for my previous two, so do it again.
Perfect.
Thanks a lot, gentlemen. And thank you everyone for joining. I'll see you next week with another session. But for now, have a great week ahead and
Thank
thank you
you.
everyone for
Thank you,
joining.
everybody.
Thank you. Bye bye.
Bye.